All right, y'all have any questions before we get going? We're going to talk about the variable class today, and it won't take that long. I think the class will be a shortish class. All right, well then let's just dive right in. I have been a little bit behind my time, and I have not yet updated the official write-up. However, the information I talk about today is basically what's going to go into the write-up, so I don't think there's anything keeping you from plowing forward. I'm hoping to have a little bit of time later this afternoon to get that updated, so stand by for that. So if I look at gpl.y, let's see, we finished up last time by kind of making this stuff very extensible. So what did we need here? We needed bin op check. Let me just throw this in. All right. Whoops. Okay. So that information that we got last time should cover all the binary expressions. You have to deal with unary expressions yourself. It should be pretty well cover that same pattern of what you did here with the template with the bin op check and the classes and all that. That leaves us with variables, and where variables come into play is not here, but rather, is that font big enough in the back? Yeah. But rather here. All right, so this is an expression that's going to get evaluated, and it'll create a multiply object here, and we have a division object here, and we have an addition object. So we have all these different expression objects being created from this expression, and this x itself we want to treat as an expression. So just as plus and multiply are classes that are derived from the expression class, variable is a class that you're going to have to create, and it is derived from the expression class. So just as we can take any expression object and ask it, we don't know what it is, we just ask it to evaluate, and we're guaranteed to get a constant back. That's the idea with this variable object. You've got an expression pointer, you don't realize that it's pointing to a variable object, but you ask the darn thing to evaluate, and it gives you back a constant object. So in this case, the example that I scratched in there on 484 and 485, where it's highlighted there, when that is asked to evaluate, it should return a constant integer object whose value is 3. So where that occurs, let me just delete that, is not, obviously it's definitely not where we've been, right? So I had the 2 lines of code that was distinguished from the variable declaration, but it's actually right here, variable. So this is the production where variables are dealt with, and looking at 480, it's as simple as it seems. When I have 3 plus y, the unadorned identifier y is what matches line 480. So we have to take some action there. And the kind of the mindset you want for the way you're thinking about things is just as here, it's a little bit obfuscated now because we have this template, right? But I guess I shouldn't have changed what I changed at the beginning of class. The essence, the motivation for having this template was so that we could bind up similar functionality as far as doing some validation of type. But in the absence of all that validation that's required, essentially what we had was $$ equals new plus, and then we had information. Okay, that's the same idea for what we want on line 480. We want to create a new object and pass it on up the chain. So we would have here $$ equals new variable, and we want to pass it information. So they're gonna have to be a few lines of code here because we need to obtain that information. So let me do it like this for now. All right. Oops. It's derived from expression like everything else. So I want to include expression.h, and I know that I am going to have to write, there's definitely some things I'm going to have to write, but one of the things I'm going to have to write is whatever is pure virtual in the expression class. So it's worth my while to jump over to expressions header file, find the pure virtual functions. So that would be these. Now, whoops, how did that happen? Note that the destructor for expression isn't pure virtual, but we are going to want a destructor for this class, so let's throw that in there. That's going to help us with our memory management. All right, so we have to, at a minimum, write those functions. We're going to have to write an evaluate function, this type, and the destructor. Let's look over here a little bit more. These two, there are 4 rules for this variable production. The last 2 rules have to do with member variables of objects, and we're not dealing with that in this project, so you need not handle the last 2 rules in this project. Just leave them be. So we do have to do the first 2, however. This one we have. This one right here is when you're doing something like that. All right? And this is a variable that we need to deal with. In fact, we note that this is not a constant integer, but is an expression. So really, all right, you have to be able to handle that kind of thing. So what we're going to get here, well, let me just ask you, what are we going to get here? Look at line 480. Let's talk about precedence. What is the very first thing to get evaluated on as far as matching a production on line 480? Thinking in terms of precedence. Which expression? The expression inside the brackets, yes. Even more specifically, the multiplication happens before addition, so y times, I'm confusing it with y, and now I'm going to have to kind of go down a rabbit hole with that, so let me change this to a 6. So what's going to happen is the 6 times 8 is going to get matched down here. It's going to match this multiply, and it's going to create a multiply object. So that ends up being the multiply object and the +2. So there will be a plus that then encapsulates this whole thing, and then we end up with an expression pointer to this entire thing here. All right? All right. So what we'll want to do is provide our variable with the matching symbol. Here, we want to provide this, the matching symbol, and the index expression, which is $3. Throw in a couple constructors. Oops. Yeah, that's fine. Let me see if I can make this shorter so it doesn't bleed over. All right. That's pretty good. I'm in variable.h, so in variable.cpp you're going to have stuff like variable, : variable. Let me just copy that. Give me the initialization list. Actually, let me start with the second one. All right. I'm going to put this on a different line just to make it more readable. Actually, let me just zoom in. That's the easiest thing to do. All right, give me the initialization list here. What's the? I've kind of outlined, if you're not real comfortable with initialization lists, I outlined kind of a recipe you can follow. What's the first thing you need to list out here as a first pass? I do it in kind of 2 passes. Anyone recall what I always do for the first pass? Absolutely. Every member variable. Here are my 2 member variables. One is called symbol. Go ahead and put parentheses. This one is array index expression. Put parentheses. And then I got my code. All right. Now the only question is what goes inside the parentheses. So what goes in here? Sim. And here is ARR IDX. We're done. Do the same thing for this other initialization list. I put symbol, I put array, index, expression, fill them in. What goes in here? SYM. What goes in here? Ah, very good. Null pointer. So that's how you can tell whether or not your variable is an array variable, is whether or not that's null. Yeah? Let me go ahead and throw out, so this is going to save you time on getting your code up to snuff with regards to memory. Say that again. If what? Yeah. Yeah. So for the sake of the recording, if a variable contains null, it is perfectly legal to call delete on it. Delete will see it's null and then not to take any action. So we don't have to check for that explicitly, which makes it really nice.
Is that a feature of the null pointer? Does it do the same thing with null?
It's a feature of delete. I want to a great extent let you all figure out this stuff for yourself. This will do the same thing we did with plus and that kind of thing. So let's look at expression.cpp real quick. If I look at evaluate, I'm just going to copy and paste a line in here. So you want to do this assignment. Give me the general process. Here's where, oops, I don't have the code anywhere convenient. When it comes time to, this has already been parsed and there's this big expression tree. This variable object is part of it. At some point in time, it's going to be the plus, right? If I go look at plus, let me go look at plus. Here it is, plus evaluate. Something asks the addition to evaluate at some point in time, right here. RHS arrow evaluate. Boom, this variable object is being asked to evaluate. Give me the general idea of what it needs to do. The information that you have is, and let's just, so it's not an array, so we can assume, looking at line 13, that array index expression is a null pointer. So the only piece of information we have to go on is our symbol on line 12. What are the things that we want to do with symbol? Yeah?
You still look up the symbol table?
Okay, so that's very important and that needs to be done. However, looking up in the symbol table is going to be done at this stage. So let's say look up symbol. Let me see, what do we want to say? Get table handler. Look up symbol $1. So the assumption is that you're actually finding the symbol. A precondition of hitting line 485 is that you found a matching symbol. So let's say that in this 3 plus y is out there somewhere in the world. You do a lookup on it, and if you look at the interface for the lookup function, it actually returns a shared pointer to a symbol. So you actually have that symbol when you hit this line of code. So well, I see what I'm doing wrong. I've got it in a different pane. So symbol on line 12 is the symbol. It is y. What it would contain. Well, what does our symbol class contain? Let's look at my symbol class. We got a name and a value. And so this value is that union at the very top of the screen there, so that value will be a pointer to either an integer, a double, or a string.
Can we access that?
That's an excellent question. Can we access it? There's no function here to get at the value, because we actually didn't need the value, right? The only time we ever look at the value in the previous project is when we call that operator the chevron operator, and we print it out to the screen. And that, of course, is accessing the private data directly. We yet don't have anything here. So I am giving you a little bit of leeway on how you want to do this. What I would counsel you do is you create functions like something like this, where you say and you can have member functions of the symbol class. I'll give you those. So here then we can basically do something like symbol as, arrow. It's incomplete. What do you need to do before? I can't just call that blind, right, the world doesn't revolve around doubles. So how am I going to figure out what kind of thing it is?
Get type.
Yeah, get the type. Switch on it. What about arrays? Excellent question. Keep in mind that, so I'm looking here, a different expression might be 3 plus the fourth element of x. So our evaluate function is still going to give us a discrete value because x sub 3 is a string or is a double or is an integer, right? So all we have to do in the evaluate function is determine whether or not it's an array. How can you determine whether or not it's an array? You could get the, yeah, I mean there are a number of different ways. A good clean giveaway is line 13. That'll be a null pointer if it's not an array, and it won't be null if it is an array. So you need the index. How can I get the index? There you go. Constant pointer. I'm just throwing in a bunch of pseudocode-ish things here. This would be the index constant, I guess. In fact, let me just dispense with this. Then
errors in this file, or printing errors in this file. Before we couldn't because we weren't sure about when it
as far as, so it's a good question. You mean what if this thing isn't an integer?
Yeah.
So if it isn't an integer, it'll throw an exception, right? And the key is, and that's fine. What you want to do is try and write your code such that, I keep forgetting I've got it over here. Write your code such that you do any validation at this level so that you will not create the variable if that index isn't an integer, right? So the example would be 3 plus x 2.95.
Yeah.
So I would not do line 491 if this was the case. I would screen for this and report an error in the at the parsing stage.
So all errors should be in GPL.y?
They can't all be in GPL.y. For instance, I can say x idx, and then at runtime I could set idx equal to -1. All right, so there's some things that have to be detected in the evaluate function. Those that are value sensitive, but anything that you're able to do type-wise should be done here in the .y file. There are all kinds of errors you can get. How about this one? Let's start fresh. Int x. What's wrong with that? It's not an array. So that has to be happening in GPL.y, right? So I don't have it here. So you want to do something like look up symbol 1 if the symbol is an array. You have the converse over here. Here, you would do something like, let me use a different double D20, and then I have an expression 3 plus D. Well, in C++, that would be a pointer. In GPL, it's an error. So that case there, whoops, I got the logic backwards. Hang on, this is the one right here. If I have 3 plus D, where D is an array, then if the symbol is an array, it's going to bomb out. I should have started down here with this one saying if the symbol is not an array, and that would have been line, where did I put that example? Right there. So here, x is not an array, and yet you're trying to access it as an array. That would trigger this error.
Still returning
0. The array index, let me see, I think it's a good question. I actually have to confess I don't quite remember. I want to say, and you just have to run through the test to reveal it. I want to say something like if there is an error that that's at the declaration stage. Yes, 0. I want to say yes, 0. At the declaration stage, I think there's something funky that happens. So if you try to create an array of doubles, you say double XYZ, and you provide -3. Well, that would have been handled in the last project. I don't know. Does that? I don't think that defaults to 0. I want to say it defaults to 1 or 2, and one of the tests reveals that. So that one may have already been handled. But yeah, so in general, like the other expressions, whenever there's a problem so that it can keep parsing, you return a constant integer 0. So if you hit any of these errors, you don't create a variable object, you create a constant integer 0. That's what you'd get on line 487 there. You'd at least get it for the index, and then you'd get the 0th item for x. So that's really all there is to it. There, you have to write those virtual functions. You have to, you're going to have to add a little bit of code to your symbol class so that you can get the value out of it. And I think that's about it. When I redid all the tests, I rearranged things so that the variables are not encountered until you've gotten all of your expressions squared away. So as long as you do your development/debugging by resolving those tests in order, then you won't have to worry about the variables until everything else is pretty good. And then that'll be nice that you're able to kind of confine your work then to this production right here.
Is there a specific way we're supposed to implement the random expression?
Yes. Nobody should be calling sran. Do not seed the random number generator. That's actually done by GPL code. It's in gpl.cpp, I believe. Okay. And I guess that is one other thing I forgot to put in the write-up. I need to put in the write-up, so I'll try and get that in later today. But you can certainly look at its behavior by looking at the GPL manual.
Yeah. Like I wrote it a way that it's random numbers, but it doesn't match the test file. But in the test file, it does say that it could be different on some systems.
Are you calling sran? Does it look like the values it's producing are correctly in the range?
I think the range 0 to 10.
Well, either 0 to 10. I think there's a test in there where it runs 15 or 20 times where it's like 47 or 48, that kind of thing. And so you should get a bunch of 47s and 48s, or whatever the two numbers are. So as long as and you can just run tests manually, right? Just call random 20 times with a very narrow range and confirm that you're not falling outside of that range. And I believe the range on both sides is inclusive. Also, the tests that involve the trigonometric functions, they give you very specific directions on the resolution of pi that you should have. There's a mathematical version of pi you can use. I believe you're discouraged from using that. And then it says make pi equal to 3.149. I don't remember where it ends, but it's very specific about that so that the output of the trigonometry of expressions ends up being identical to what's in the tests.
I think it was odding at 1.
Did I get it wrong? Is it it does want you to use MPy?
Yeah.
Maybe I'm thinking. All right, then I must be thinking of something else. At any rate, where there's oddities like that, the key is, so there are three things, right? When you get a test that fails, you need, if the standard out is different, run that VD utility to look at the difference in the standard outputs. If standard error is buggy, then look at the VDE comparison for that. But the third thing is you always got to crack open that GPL file and see what it looks like. Because in addition to understanding what the precise test is, oftentimes if there's something quirky, there will be a comment in there explaining what the quirk is. Anything else? All right. So you don't get out of this project without writing fewer than 700 or 800 lines of code. Don't wait till the last minute. I don't know how else to say it. There's no way to write that much code in a very short period of time. So you got to do something between now and Tuesday, and then attack me full force with your concerns on Tuesday. All right? Okay, then like I said, this would be a bit of a shortish class, so I will stop here. I am going to try very hard to finish getting that write-up done, but I think everything we talked about is all that's going to be in the write-up. Okay?